Stargate. The name alone conjures up a sense of sci-fi ambition, and fittingly, it's become the codename for what is poised to be the world's most colossal AI infrastructure project. Deep in Abilene, Texas, a town on the windswept Central Plains, the first buildings are rising on a 1,200-acre campus. By the time this project, dubbed Project Ludicrous, is finished around 2026, it will house 8 massive data centers, each packed with the fastest, most advanced AI chips on the planet. The scale of this operation is almost hard to comprehend. Backed by Openai, Oracle, and SoftBank, Stargate's founders envision up to $500 billion invested over the coming years. Already, more than 2,200 workers from across 7 states are on site, operating around the clock. When completed, these 8 buildings will contain roughly 400,000 GPUs, each one a specialized chip designed to handle the massively parallel computations required to power next-generation artificial intelligence. The push for Stargate isn't happening in isolation. Tech giants worldwide, Microsoft, Meta, Google, Amazon, and Elon Musk's XAI, are racing to build their own AI superclusters. The stakes are more than just corporate bragging rights. At the center is the quest for AGI, or Artificial General Intelligence, an AI capable of reasoning and learning at or beyond human levels. As models like ChatGPT and its successors consume more compute power and gain more users, the appetite for dedicated infrastructure has surged far beyond what anyone anticipated even a few years ago. But why Texas? The answer lies in the region's wealth of low-cost, clean energy, mainly wind, untapped demand, and wide-open space for sprawling development. These aren't just traditional data centers. While the first generation of cloud computing was built using conventional CPUs clustered around hubs like Northern Virginia, Stargate epitomizes Data Center 2.0. Vast halls loaded with specialized GPUs, all interconnected for AI's unique needs. Building infrastructure on this scale brings up immense engineering challenges, one of which is keeping all those hard-working chips cool. GPUs run hot, and traditional cooling uses millions of gallons of water, raising serious sustainability concerns. Crusoe, the company spearheading Stargate's construction, claims their solution is a closed-loop water system, 1 million gallons filled once, then circulated indefinitely within sealed pipes, greatly reducing environmental impact. But chips alone won't cut it. AI requires prodigious amounts of energy. To put this in perspective, 20 years ago, a rack in a data center might consume 2 to 4 kilowatts. Today, a rack of NVIDIA's latest GPUs is budgeted for 130 kilowatts. Even a single ChatGPT query uses roughly 10 times the electricity of a Google search. Stargate's first phase in Abilene will draw 1.2 gigawatts, enough to power 750,000 homes. Across America, if this trend continues, data centers could consume more than 8% of the nation's electricity by 2035. While half of that increased load may be met by renewables, the reality is that fossil fuels will still play a substantial supporting role. On top of energy, the project raises broader questions about sustainability, climate goals, and the true cost and benefits of such infrastructure. Crusoe's founder, Chase Lockmiller, brings a unique background to the venture, having previously worked in AI-driven finance and innovated in the world of crypto mining by repurposing otherwise flared natural gas to power mobile data centers. This experience with energy-hungry, modular technology made him well-equipped to tackle the logistical and technical problems posed by Stargate. The business side is daunting. Will all this investment pay off? AI research is moving fast, with new models being built more efficiently. Chinese company DeepSeek, for example, achieved impressive results with far less infrastructure. Still, proponents argue that cheaper, better AI will spark even greater usage, keeping demand for superclusters sky high. Critics wonder if the scale of investment risks a bubble or bust should usage plateau, or if ongoing efficiency gains render some infrastructure obsolete. At the same time, Stargate's impact on Abilene and other host cities is a mixed bag. Local officials hope for millions in new tax revenue and jobs, though actually permanent headcount for data centers is relatively modest, often more maintenance and security than high-paying tech jobs. To attract the project, Abilene agreed to give up 85% of property tax revenue from the site, betting that even 15% of billions is a boon for city services. Locals show a blend of pride, excitement, uncertainty, and anxiety. Some are thrilled to move beyond an economy dominated by oil and agriculture. Others express concerns about the environmental impact, power usage, or the risk of AI automation overwhelming existing job markets. The fear of rapid, unpredictable change is present, even among technology's architects, especially as advances move from software to physical robots suddenly appearing in daily life. Geopolitics also looms large. Much of the hardware and materials used in data centers are built through globally integrated supply chains, with advanced chips mostly fabricated in Taiwan, Korea, and Japan, and critical components flowing through China. Trade and tariff decisions have added tension to this delicate balance, and both American and Chinese companies are racing to lead the AI revolution. Allies, too, increasingly seek a stake. Countries with abundant renewable resources, like Iceland and Singapore, are vying for their own slice of the AI data center boom. Ultimately, Stargate stands as a symbol of the unprecedented infrastructure race powering the frontiers of artificial intelligence. Whether or not $500 billion is ultimately spent, and whether every big bet pays off, one thing is certain. Humanity is building the superhighways for the age of intelligent machines. As history shows, such leaps forward always bring disruption, opportunity, and risk in equal measure. Only time will reveal what's truly on the other side of that wormhole. But whatever it is, it promises to be unlike anything we've seen before.